think 2 years ago. Thank you. It's absolutely critical to maintain these capabilities. I always say everyone wants to use them, nobody wants to pay for them. But you lose a Cat 2 radiological facility, it's $1 billion replacement, and you'll never get it back. So we're absolutely committed to maintaining those capabilities. Our mission right now is scientific discovery as an Office of Science lab. Our focus is energy resiliency and national security. By the way, most of that national security is non-proliferation work. We don't do weapons work. At the heart and soul of what we're good at is chemistry, earth sciences, and data analytics. You can imagine having grown up at the Hanford site, which was mostly chemical processing, and that's what we supported. We're material science, chemical engineers, chemists at the heart and soul. Unlike a lot of laboratories, we don't have a big physics facility, so we are not a physics-dominated lab. We're a chemistry and material science-dominated labs. And our focus is on protecting the electric grid, next-generation energy storage, cybersecurity, and then nuclear non-proliferation. And I'm going to just walk through the 4 main research areas at the laboratory, but I'm not going to go into great detail, just to give you a feeling for the breadth and depth of what we have here. On the fundamental science side, which would normally be Office of Science work, and this is true discovery-based work, we're very strong in the Earth system science, and we support a lot of the work on climate models from around the world and the regional models. We actually own the airplanes and others that go out and measure certain things in the atmosphere and then feed that back to the entire community in the world to do R&D on that. We're very strong in chemical and material sciences, one of the top labs on materials processing, synthesis, and the chemistry at interfaces. And then we have a DOE user facility. EMSL stands for the Environmental Molecular Science Laboratory. It is right over there. It's a large building. It was about a $250 million investment, about $40 million a year, and it's got state-of-the-art surface analytical equipment. And it fits into our nuclear portfolio in that we are very good at characterizing what goes on at interfaces, material structure, and the chemistry, and the processing of materials, and it matches up to the work that we have in our radiological facilities as well. You know, it's very expensive to do everything in a radiological environment, so we like to get the dose down and move samples to other equipment when possible. The national security side is shown here. Very strong in the non-proliferation. I forget the exact numbers, but over a 5-year rolling period, we might have people in 140 different countries around the world. And what we are primarily good at, you might imagine, having grown up next to the Hanford site and understanding the materials processing at the front end and actually at the back end of nuclear materials processing, we're very good at understanding signatures and unraveling the organic chemistry and/or inorganic chemistry that goes along with those signatures. Very good at measuring very small amounts of radiation based on our history, and that's allowed us to grow into a lot of other areas like rad-nuc, monitoring, detecting, chem-bio, and explosives detection. Then we have a very strong, in today's world, cyber activity that wraps an envelope around everything that we do, both the management of the laboratory, the management and detection of cyber attacks for the entire DOE system, and private industry as well in certain areas like the grid. Oh, this one, if you're not familiar, that device, you know, everyone in